Forget the big one. Something far worse is coming. Earthquakes, unfortunately, remain unpredictable. However, thanks to significant advancements in geology over recent decades, we can at least identify regions where conditions are ideal for their occurrence. The Earth's crust consists of various tectonic plates, massive sections of the crust, and to some extent the upper mantle, that constantly shift, much like pieces of an enormous puzzle. Alongside the 20 primary plates, there are also smaller ones known as microplates. The areas where these tectonic plates meet are called subduction zones, where a smaller or less dense plate is forced beneath a larger one. Many of these regions, such as Chile and Japan, are well known for the devastating earthquakes they have experienced. Meanwhile, another area frequently discussed is California, which is intersected by the San Andreas Fault. The infamous Big One is often predicted to strike this region, potentially causing catastrophic damage. However, what lies ahead just slightly north of California is even more concerning. Along a stretch of coastline dominated by the Cascade Range, a disaster of much greater magnitude is looming. If the Big One is feared, what's coming could be considered the Big One cubed, a catastrophe that locals have already begun calling the really big one, with a mix of concern and grim acknowledgement. While the world often fixates on the San Andreas Fault and the potential destruction of California, a well-researched and thoroughly documented study has revealed that a much more severe earthquake is likely to devastate a less discussed region, the Cascadia Subduction Zone. This area, located off the northwestern Pacific coast, has become the focal point of extensive research in recent years, as mounting evidence indicates a history of recurring mega-earthquakes followed by even more destructive tsunamis. The Cascadia Subduction Zone lies approximately 200 kilometers off the coast and extends roughly 1,100 kilometers from Cape Mendocino in Northern California to Vancouver Island in Canada. The name Cascadia comes from the Cascade Mountain Range, which runs parallel to the coastline. Experts now believe this fault is capable of producing earthquakes of magnitude 8 or 9, on par with or even more devastating than the ones that struck Indonesia in 2004 and Japan in 2011. At the heart of this seismic threat is the collision between the Juan de Fuca and Gorda plates, which are being pushed beneath the North American plate. Though these plates move at a slow but steady pace, they are currently locked at their points of contact. Eventually, the accumulated energy will overcome the friction holding them in place, triggering what could be described as the greatest natural disaster in North American history. Why haven't we heard more about this? There are several reasons why this impending catastrophe hasn't gained the same level of attention. One is the overwhelming influence of Hollywood, which has conditioned audiences to associate ultimate disaster with the destruction of Los Angeles. Another is the relative obscurity of the affected region. Places like Oregon and the Canadian border tend to be far less in the media spotlight. For many years, scientists underestimated the seismic potential of the Pacific Northwest. Before the mid-1980s, it was widely believed that the only tsunami threat to this region would come from distant earthquakes, providing ample warning time. Local tsunamis were not considered a significant risk. This assumption was largely based on the absence of written records detailing past events, leading to the mistaken belief that the Cascadia Subduction Zone was incapable of producing massive earthquakes. Until about 40 years ago, the existence of the Cascadia Subduction Zone itself was unknown. The last major earthquake in the region had occurred centuries earlier, long before European colonization of the Pacific coast. The land was inhabited by indigenous tribes who did not use written records, meaning no documented account of the disaster existed. As a result, early settlers saw the area as fertile, mild in climate, and seemingly free of natural dangers. It wasn't until the late 20th century that scientists began piecing together evidence suggesting the region had merely been in a long period of seismic dormancy. The breakthrough came from studying global earthquake patterns. Almost all of the world's most powerful earthquakes occur along the Ring of Fire, a geologically volatile region encircling the Pacific Ocean. This seismic hotspot extends from New Zealand through Indonesia and Japan, then across the ocean to Alaska, and down the western coasts of North and South America. A look at recent history confirms the destructive power of subduction zones. Japan 2011, magnitude 9.0. Indonesia 2004, magnitude 9.1. Alaska 1964, magnitude 9.2. Chile 1960, magnitude 9.5. It was only with the development of plate tectonic theory in the 1960s that scientists began to understand this pattern. The Ring of Fire, they realized, is actually a vast collection of subduction zones where oceanic plates are being forced beneath continental ones, leading to earthquakes and volcanic eruptions. The clue from Japan. For years, scientists were puzzled by an apparent gap in the Ring of Fire. Why did the northwestern Pacific coast show no significant signs of past seismic activity? The answer finally emerged from historical documents in Japan. Researchers discovered ancient records describing a massive tsunami that struck the Japanese coast centuries ago, one with no apparent earthquake origin. This orphan tsunami, as it was called, remained a mystery until the 1990s. Then, in 1996, scientists were able to trace the source of the tsunami back to January 26, 1700, when a magnitude 9.0 earthquake ruptured the Cascadia subduction zone. Indigenous oral histories from the Pacific Northwest also contain references to the event, describing powerful tremors and enormous waves. While these stories had long been dismissed as folklore, they were in fact historical accounts of a real and catastrophic event. By analyzing geological records, researchers have since confirmed that Cascadia has experienced at least 41 major earthquakes over the past 10,000 years. These quakes occur at irregular intervals, meaning there is no precise way to predict the next one, but the data suggests we are now overdue for another massive event. How do we know? When a massive underwater earthquake occurs, it triggers powerful landslides along the continental shelf. These landslides leave behind layers of sediment in the ocean floor, called turbidites, coarse deposits that stand out clearly from the fine-grained sediment that accumulates under normal conditions. By analyzing these deposits, scientists have been able to reconstruct a timeline of past earthquakes in the region, providing further proof that Cascadia is not a quiet zone, but a ticking time bomb. The question is not if the really big one will happen, but when. By analyzing fine particles using carbon-14 dating and other scientific methods, researchers can determine with remarkable accuracy when major earthquakes have struck over the past 10,000 years. Dividing 10,000 by 41 results in an average interval of 241 years between major seismic events in the Cascadia region. This time frame is particularly concerning for two reasons. It is long enough for civilizations to develop over one of the most hazardous fault lines in North America, yet not long enough to dismiss the likelihood of another disaster occurring soon. It has now been 315 years since the last major earthquake in this cycle, which typically recurs every 241 years on average. Of course, recurrence intervals are merely statistical estimates, just as an average of 10 could result from both 9 and 11, or from 2 and 18. Nonetheless, geologists have recently estimated a 37% probability of an earthquake of magnitude 8.2 occurring within the next 50 years, and a 10 to 15% chance of a full rupture of the Cascadia subduction zone, resulting in a catastrophic 9.2 magnitude quake within the same 50 years period. Eventually, the compressive forces between the tectonic plates will surpass the friction that holds them in place, triggering an abrupt and violent shift, what scientists describe as the North American plate springing back with immense force. From that moment onward, the consequences will be devastating. A megaquake exceeding magnitude 9 will send powerful seismic waves across the Pacific. The initial tremors, ranging between magnitude 7 and 8, will hit the coastline first. The entire northwestern region of the continent, from California to Canada, will subside by at least 2 meters and shift westward by as much as 10 to 30 meters. This violent shaking will bring down older buildings, collapse bridges, trigger landslides, and cause soil liquefaction, a phenomenon where solid ground temporarily loses its stability, behaving more like liquid and swallowing structures above it. Furthermore, part of this land movement will occur beneath the ocean, displacing an immense volume of water. The resulting tsunami will first rise into a massive wave, then collapse as it surges outward. One portion will rush westward toward Japan, while the other will head toward the North American coast. Within approximately 15 minutes of the earthquake, a towering wall of water, spanning hundreds of kilometers, will crash onto the shoreline, leaving residents with little time to evacuate. Estimated wave heights range between 9 and 12 meters, though some models predict they could reach up to 30 meters in certain areas, pushing as far as 20 kilometers inland. The affected region covers around 360,000 square kilometers, encompassing major cities such as Seattle, Tacoma, Portland, Eugene, Salem, Oregon's capital, and Olympia, Washington's capital, home to approximately 7 million people. When the next major rupture occurs, this area will experience the most devastating natural disaster in North American history, excluding the 2010 Haiti earthquake, which resulted in over 100,000 fatalities. By comparison, the 1906 San Francisco earthquake claimed roughly 3,000 lives, Hurricane Katrina caused around 2,000 deaths, and Hurricane Sandy led to nearly 300 fatalities in 2012. In contrast, projections for 2015, the impending really big one, in Cascadia estimate that the earthquake and tsunami will kill approximately 20,000 people, injure 40,000, and displace at least 2 million residents for months. While these figures may seem modest compared to disasters in more densely populated parts of the world, the potential devastation remains staggering. Does this mean we are powerless against such an event? Not necessarily. When researchers first realized decades ago that the Cascadia Fault would eventually unleash a massive earthquake, there was little understanding of how to mitigate the effects of the resulting tsunami. This lack of preparation continued until 2004, when the catastrophic Sumatra tsunami prompted US and Canadian authorities to invest in advanced early warning systems. Today, sophisticated satellite-based detection networks continuously monitor even the slightest changes in sea levels. For the Pacific coasts of the US and Canada, earthquake alert centers can now issue warnings within 5 minutes of a major seismic event. In the case of a Cascadia rupture, this would provide coastal populations with approximately 25 minutes to reach higher ground. While that may not seem like much time, it is a crucial window of opportunity, because what we are dealing with here is not just any natural disaster, but the really big one.